Okay, guys, this is the second video. I put the data in L1. I put all the counts that were given in the problem, and in L2, I put the expected value counts. All right, let's go back to stat, test, and the GOF test. Okay, L1 is the observed, L2 is the expected. I told you how to get the degrees of freedom. That was the total number of categories, the total number of elements, minus 1. It's not the total number of accidents, not 699 minus 1. Let's calculate that and see what it looks like. So this chi-square value is 208.757. That really shouldn't mean anything to you, but you're going to have to write that value down. The more important thing is this p-value. It's as close to 0 as humanly possible. It has like a 41 zeros and then followed by a 2. So this is as close to 0 as possible. Let me write these numbers down. So what we have is we have a chi-square of 208.757 with an associated p-value of practically 0. And we would obviously, when we know what happens when we get a small p-value, we would reject the null hypothesis. Remember to please always express your answer thoroughly. With a chi-squared value of 208, again, we don't know if that's a big number or not, and a p-value of 0, we certainly know what that means. We reject the null, and then what we would say is, in this particular context, the accidents, I should say, let's put it this way. The distribution of accidents is not uniform. Actually, better yet, I should say this. We have very, very strong evidence to say that the distribution of accidents is not uniform. Day to day, during the week, we should expect different levels of accidents. Okay, so that's actually how you conduct a chi-square goodness of fit test. And we'll take a look at some more details now. Let's go back now and talk about some of the conditions. Well, one of the conditions that you have is that every expected count, the expected counts have to all be more than 5. There's actually a small a discrepancy with that, where we can actually say that it could be, some can actually be less than 5 as long as it's not 20% or more of them. In other words, suppose this expected count was 3, but the other ones were all 99, we still meet the condition. So this is what the condition actually says. You may use this test when all individual expected counts are at least 1 and no more than 20% of the expected counts are less than 5. Sometimes we check to make sure that all expected counts are at least 5, but this is a stricter condition and much harsher than sometimes needed.